Hi friends, here are some basic problems on limits. Right, what is a limit? We say, let's say this is the function x minus 5 by x square minus 25. This is the function. What will be the value of this function when x approaches 5? When x approaches 5, that means 4.9, 4.99 or 5.01, 5.001, whatever. When x is approaching 5, what is the value of this function? Clearly, this function is not defined when x equal to 5 because the denominator becomes 0. Right. So it is not defined. So what we do in such cases, we simplify this and we create an identical function, which is actually defined at x, x at 5. And then we say that that is the limit. For example, like this. This function clearly is not defined at x equal to 5. What we do, we'll break this into factors. We want to remove x minus 5 from this. Right. Whenever the denominator is becoming 0, we want to remove that factor. Okay. So x minus 5, the denominator we can write it as x minus 5 into x plus 5. And if we to cancel both of them, then this is an identical function to this. This function is equal to this function except when x equal to 5. Because at x equal to 5, we are cancelling 0 by 0, which is not possible. For every other case, this function is equal to, on all other cases of x, this is equal to this. So now with this function, we can say we will use this function as guide, right? To say what will happen, what is the value of this function when at x equal to 5. So when x is tending to 5, value of this function is 1 by 10. So now this function at x tends to 5, it is not defined, but this function will behave like this function for all the values of x, except when x equal to 5. So how does this look like? The graph of this function, 1 by x will look something like this, right? We know 1 by x will look something like this. So 1 by x plus 5, f of x versus f of x plus 5. So this graph will shift 5 units to the left. So how will the graph will look like now? The graph, if let's say this is 5, this is minus 5, the graph will look something like this. Okay? This graph will look something like this. This graph. Here, when x tends to 5, x tends to 5 somewhere, this point was missing. Whatever this point in this graph was missing, but this in this graph, this point is what? This point is 1 by 10. This point is actually 1 by 10. So we say this graph, when x is tending to 5, when x is tending to the 5 from the left side or from the right side, this point, the function is approaching 1 by 10. The function is not 1 by 10. Here we are saying the function is approaching 1 by 10. Whether x tends from 5, it will tend from left or it will tend from right. F of x will approach 1 by 10. This is what we are saying. Similarly here, x tends to minus 5. So clearly we cannot directly say what will happen to this function when x equal to minus 5 because the denominator becomes 0. So we have to find some other function which will act as an identical function. So what does that mean? We have to factor x plus 5 here and cancel that. So what we do? We can write this as x plus 5 into x minus 2, right? This we can write it as x square plus 5x minus 2x minus 10, right? The numerator. So we can factor it like this. Now x plus 5 will get cancelled whenever x is not equal to minus 5. Right, we can cancel this. For all the cases when x is not equal to minus 5, this function and this function are same. Okay, so but this function is defined at x equal to minus 5. So this function is saying when x equal to minus 5, the value of this is minus 5. So obviously this function should, the limit of this function should be equal to minus 5, right? Similarly here when t is 1, this function is not defined. So we have to eliminate t minus 1, right? We have to find some other function which will resemble this, which is identical to this, but which is defined at t equal to 1, right? So let's, what will you do? T square minus 1 will write it as t minus 1 into t plus 1. Similarly, the numerator also we can factorize, right? T square plus 2t minus t minus 2. We can write it like this, right? Then we'll factor this. This t minus 1 and t minus 1 we can cancel. We'll be left with t plus 1, t plus 2 by t plus 1. This function is actually defined. This one we can directly uh, substitute one. Sorry, right? So this one is identical to this one, except at t equal to 1. T equal to 1, this is defined, but this is not defined. So we'll say this function, the value of this function is 3 by 2, when you substitute 1. So the limit, this function is approaching 3 by 2 when t is moving towards 1, whether from left side or from the right side. Okay, then this function f of t, whatever you call it, f of t is approaching 3 by 2. This is what we are saying. Right, let us take one more case. Another case. Here v cube minus 8 by v power 4 minus 16. V is approaching 2. Here again, if 16 minus 16 will become, so it is useless. We have to remove v minus 2 from the denominator. How do we do this? Let's factor this. This is in the form of a square minus b square. That is v square whole square minus 4 square. Right. This becomes v square plus 4 into v square minus 4. Now again, v square minus 4 into v square plus 4. Okay, v square minus 4, again a square minus b square, we can write it as v minus 2 into v plus 2 into v square minus v square plus 4. Right, why we are doing this? Because we want to eliminate v minus 2. Now this is in the form of a cube minus b cube, a minus b into a square plus ab plus b square. Right, so we are eliminating v minus 2 here. So this function is identical to this function, and this function is actually defined at v equal to 2. So what is the value of this function? We will say this the value of the limit is actually equal to the value of the limit for this function, right? So this function is actually defined also. So in this case, for this function, let's say this is g of v. For g of v is equal to limit v tends to 2 g of v. For this function, g of 2 is also equal to this. But for this function, let's say if it's called f of v. For this function, f of 2 is not defined. Not defined. For this function, it is not defined. If we are calling this as f of v, this function f of 2 is not defined. But limit v tends to 2, f of v is actually defined. Okay, that is or 3 by 8. Please note the difference. F of value of the function, let's say f of x, when x tends to x naught, this if there is a limit, this can be defined. But f of x naught need not be defined. Okay, this need not be defined. Right. See, for example, here, limit v tends to t, f of v, limit is defined. But f of v, f of 2 is not defined. F of 2 is not defined. But limit, this one is defined. Okay, in all these cases. Now let's take this case. F of x, let's say this is f of x. F of 4 is not defined. Why? Because 2 minus root 2 is becoming 4. F of 4 is not defined. But limit is defined. How do we calculate this limit? We want to eliminate this 2 minus root x. How do you do this? We have to find a common factor. Okay, 4x minus x square. Let's take x common. 4 minus x. 4 minus x is nothing but 2 square minus root x whole square. Right, this is also a square minus b square. What we will do? We will write it as 2 minus root x into 2 plus root x. How are we getting this idea? How are we getting this idea? Because of this denominator only. This is a 2 minus root x. So we are trying for a 2 minus root x here. That's why we got this idea. We got this idea of writing 4 minus x as 2 square minus root x whole square. Right. So the denominator is giving this idea. Now this 2 minus root x will cancel. So this function, now whatever our original function is actually identical to this function now. Okay, this function is defined at x equal to 4. Okay, let's say if this is g of x, g of 4 is defined. G of 4 is defined. If this is f of x, f of 4 is not defined. But limit x tends to 4, we call it f of 4, f of x is equal to limit x tends to 4 g of x. In both cases, the limits are defined. Okay, because both the functions, the value is approaching 16. Okay, if you substitute 4 here, then this becomes 4 times 2 plus root 4, which is 2, 4 times 4, which is 16. Both functions, if you draw the graph, whatever the graph looks like, they are approaching 16, both functions. In this case, that 16 point is missing. That is a hole. But in this case, it is a continuous function, 16 point is defined, right? But in this case, it's a hole. It's a hole, though, except that 16 point, the point of 16, we can get 15.9, we can get 15.99, whatever, 16.01, 16.001, all this we can get. But in this case, all this along with 16. In the first case, the 16, only the point 16 is missing. Rest all you can find. However close you want to 16, you will find. In the second case, you will find 16 also. That's the only difference. That's why we say this function, the limit is actually 16 because only the point 16 is missing. Here, 16 is also included. So in this function, g of 4 is equal to limit x tends to 4 g of x, limit and the value of the function is same. In this case, the value of the function and limit are not same because the value of the function is not defined. Very basic problems. The goal is to identify some other related function, some other identical function which probably can be defined at the point which we are concerned. Okay. And what is the idea of limit? Idea of the limit is this function, though it might not be defined at this point that we want, we still want to know how this function behaves at this point. Is this function approaching some common value, some common limit? We call that limit some common L. Some L, whether you are approaching from the left side or from the right side of this x, right? Whether you are approaching 5 from left side, that is 4.9, 4.99 and all, or approaching 5 from the right side, which is 5.2, 5.1, 5.01, 5.001, whatever. Right. Whichever case, if this function is seemingly approaching some value, let's say if you take a calculator and try to calculate this one, try to calculate by using inputs like x tends to 4.9, 4.99, whatever, like this. Then you will get this value, right? You will get the value which is very close to 1 by 10. Similarly, in all these cases, all these cases, in this case, if you try to use a calculator and try to calculate this value, when x is 3.9, 3.99, or 4.01, whatever, you'll get a value which is very close to 16, except 16. 16 you cannot get in this. Right, guys? That is the broad meaning of limit. This is not the precise definition. Precise definition we'll come to it later. But broad definition is this value of this function when x is approaching 5 should approach the function should approach some value, whether you are approaching from the right side or from the left side. Okay. Hope you like this. Thank you.